Hello everyone. In this video we're going to be comparing two numbers. We have 999 factorial and 500 to the power 999, and we're going to figure out which one is greater. I'll be presenting two methods, and before we get started I want to show you how large these numbers are. How large do you think these numbers are? Can we estimate or find out how many digits these numbers are going to have? Obviously, by using logarithms we can figure out how many digits the number 500 to the power 999 has, but 999 factorial is not going to be that easy. But anyways, when we put it into Desmos, this is what we get. It says undefined for both of these numbers because they're very large. And Google doesn't give us a definite answer either. It says undefined, but when we look up 99 factorial, we get a number, a very gigantic number, by the way, with 156 digits. So even 99 factorial is super duper large. Imagine how large this number can be. I haven't tested out Wolfram Alpha. It's going to give you a definite answer for this one. Great. And another large number that is well known is Google, not the website Google, but the number Google, and it has basically 100 zeros. That follows 1. And interestingly, it's also called 10 duotrigintillion. I kind of find that name interesting and funny too. Anyways, let's get started with our numbers. So I'll be presenting two methods, as I said earlier. Let's start with the first method. My first method is going to involve a little bit of algebra, but not too heavy. So I'm going to be looking at 999 factorial first. So what is that supposed to mean? It just means that you can just, expand it. 999 times 998 and then ... In the middle, I'm going to have something like 500, obviously, and then it's just going to go 3, 2, and 1. So all the product of all these numbers, right? Now, I want to make some pairings here, and I want to make it in a smarter way. So I want to pick two numbers from both ends and put them together such that the sum of the numbers is always 1,000. So 999 is going to go with 1, and then I'm going to use 998 with 2, so on and so forth. But what's going to happen at the end of this is that 500 is not going to pair up with anything. We have an odd number of numbers, so we're going to have a leftover, and since there's nothing that 500 can pair up with, it's just going to stay alone. Now, this tells me that I can kind of put it in an algebraic form, like what? For example, if my one of my numbers is n, since their sum is 1,000, then the other number needs to be 1,000 minus n, because if I ask you to find two numbers whose sum is 1,000, you could say n and 1,000 minus n, right? And if you distribute, you get 1,000 n minus n squared. Great. So here's what I'd like to use. I want to get this expression. If you kind of reverse the expression here or negate, you're going to get something interesting, and that is going to be a perfect square. So let's consider, and it's not just out of the blue, obviously. If you consider n minus 500 quantity squared, you're going to notice that you get n squared minus 1,000 n plus 500 squared. Sorry about that. Why did I write it as 500 squared? I could write it out like 25 whatever thousand, I think, right? But that's not important at this point. It's better to keep it as 500 squared. Why? Because we have 500 in our product. So obviously this is going to be greater than or equal to 0, right? You would agree that. Now, I want to leave the 500 squared alone on the left-hand side and put everything else on the right-hand side, and that's basically going to negate n squared minus 1,000 n, which is going to turn that into what I want, 1,000 n minus n squared. Great. So since the n minus 500 squared is a perfect square, we can safely say this is true, right? Now, but 1,000 n minus n squared can be factored as n times 1,000 minus n. So we kind of got like interesting relationship that 500 squared is always going to be greater than or equal to this product. Nice. So if I use n equals 1, obviously this is going to be true all the time, but if I use particular values like n equals 1, for example, this is going to give me 500 squared is greater than or equal to 1 times 999. And then if I keep doing it, 500 squared is going to be greater than 2 times 998, ... And now you're going to notice that we're not going to use 500 because it doesn't pair up. So I'm going to end with the two numbers that are in the middle, but kind of like excluding the 500. So those numbers are going to be 499 and 541, right? Obviously, they're going to be in the middle, sort of. So now we're done because we pretty much considered all the numbers except for 500, which didn't pair up. Now, I'm going to do something that we do a lot. Multiply these together. When I multiply, now, so here's my goal. First of all, I was able to compare 500 squared to something like this, and then I kind of kept doing it. So that way, on the right-hand side of my inequality, I'm going to get something like 500 factorial. 999 factorial. Of course, it's not going to be completely that, but it's going to be super close. Okay, great. So hopefully you got the point here. On the left-hand side, now notice that I have 499 rows. So 500 squared is repeated. 500 squared is repeated 499 times. Great. And on the right-hand side, I have 999 factorial, but I'm missing 500. So I just need to divide by 500 so that I can set them, I can set it equal to the product on the right-hand side. So what does this give me? Great. This gives me 500 to the power 998 is greater or equal to 999 factorial divided by 500. If you multiply both sides by 500, which is a positive number, you get 500 to the power 999 is greater or equal to 999 factorial. Obviously, there is no way they can be equal, but the equality comes from the fact that, these numbers are equal. So if, for example, in a perfect square, if n is equal to 500, then obviously that's going to work, but otherwise it's not going to be the equality. So we can safely say that this implies that 500 to the power 999 is the greater number. All right, that concludes our first methods. Let's go ahead and take a look at the second method. My second method is kind of different, I think. Hopefully you'll find that different too. So let's take a look. Using my second method, I'm going to start off with something weird. I know it looks weird, but think about this. We're comparing 999 factorial and 500 to the power 999. So it kind of makes sense to take the 999th root of both sides. So I'm going to take the 999th root of 999 factorial, and this is going to give me something like this. If you expand it, you're going to get 999th root of 999 times 998, all the way up to 2, 1, so on and so forth, right? So that's a radical expression. Now, at this point, I'm going to use the AMGM inequality. What does AMGM inequality tells me? It tells me that the arithmetic mean of a bunch of numbers is always greater or equal to their geometric mean, and the equality is attained when all the numbers are equal. In this case, obviously, they're different, so it's just going to be a strict inequality. So I can safely say that the 999th root of this product, right, which means the geometric mean of all these numbers, 999 numbers, is going to be less than their arithmetic mean, which is their sum, right? Their sum divided by the number of numbers, which is 999. Great. Now, the right-hand side on the top, I can basically evaluate it, right? So let me go ahead and turn this into the 999th root of 999 factorial, because that's what I'd like to have at the end, is less than. Now, if you look at the top, it is actually n times n plus 1 divided by 2. So that sum can be expressed as 999 times 1,000 divided by 2, and that 2 can be easily multiplied by that. So that's the sum that I get from the top, and I'm just dividing it by 999. I hope that makes sense. 999 cancels out, and guess what? We're getting 500 here. Yay! Awesome, beautiful. So this result gives me the 999th root of 999 factorial, that's a mouthful, is less than 500. Now, since both of these quantities are positive, I can raise both sides to the power 999, and that gives me 999 factorial is less than 500 to the power 999. Therefore, the larger number in this case is going to be, again, 500 to the power 999, as we figured out with the first method. And this brings us to the end of this video. Well, thank you for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you tomorrow with another video. Until then, be safe, take care, and hasta la vista.